Consider a box with 4 blue pens and 3 red pens. The sample space is 7 pens. A pen is picked at random, its color noted, and is pressed back in the box. Either a red pen can be picked, and the probability will be 3 out of 7, since all red pens have equal chance of being picked, or a blue pen can be picked and the probability will be 4 out of 7, since all blue pens have equal chance of being picked. Note that the pen was pressed back in the box, implying that in the second picking, the sample space will remain the same. A second pen is then picked and its color is noted. Note that if a red pen was picked first, then the probability of picking a red pen second is 3 out of 7 and a blue pen is 4 out of 7. Alternatively, if a blue pen was picked first, then the probability of picking a red pen second is 3 out of 7 and a blue pen is 4 out of 7. Therefore, the possible outcome of picking a red pen in the second picking is either a red first and a red second, or a blue first and a red second. The probability of picking a red pen first and a red pen second is 3 out of 7 times 3 out of 7. We multiply the probabilities because of the word "and", since it is a red and a red. These events are also called independent events, since picking the first color does not stop the picking of the second color. Then the probability of picking a blue pen first and a red pen second will be 4 out of 7 times 3 out of 7. Thus, the probability of picking a red pen second would be probability of a red first and a red second plus probability of a blue first and a red second. We add because of the word "or", since the two outcomes are not the same and are said to be mutually exclusive. Therefore, the probability of picking a red pen second is 3 out of 7 times 3 out of 7 plus 4 out of 7 times 3 out of 7, and this becomes 21 out of 49, which further reduces to 3 out of 7.